Okay, so let's talk about upthrust, okay? We've all experienced upthrust, okay? It's why you float if you're in a pool. It's why when you push the football under the water, it pings up back and hits you in the face unexpectedly. It's why all of these kind of really cool things happen. It's why boats can float even though they're flipping huge, right? It's all to do with upthrust, okay? And it turns out that upthrust can be very elegantly explained, okay? So check out this tutorial video where I talk about upthrust, what it is, and how we actually derive an expression for it. Okay, let's talk about upthrust a little bit more. So what is upthrust? Or you might have heard it referred to as buoyancy. Buoyancy or upthrust is effectively the upward force that is exerted by a fluid that opposes the weight of an object that is either completely or partially submerged in that fluid. This is why you float sometimes, right? It depends on the density of the object, but this is why things float, right? So when weight exceeds the buoyant force, things sink, and when it's the other way around, things float, okay? So that is what upthrust is, and upthrust, if we're going to look at it in a bit more detail, which is definitely worth doing, it's actually generated by a difference in pressure between two different surfaces of an object that is submerged. So that makes upthrust a resultant force, and I think the best way to explain that is to use this diagram here that I've drawn, right, and treat the surfaces as two different things, right? So here we have the top surface and here we have the bottom surface. So because pressure under a fluid is equal to rho times g times h, right, we can say that the force that is exerted on the top surface area is equal to rho g h a. Okay, and we can say that the F on the bottom surface is equal to rho g a times x plus h, right? And that's because the distance between the top of the water here and the bottom surface is equal to h plus x, right? There's h and there's x, so you add those together, okay? Now, if you calculate the resultant force here, then what you're going to be doing is, so Fr is equal to h plus x rho g h, right, minus rho g h a, which gives us x rho g a, okay? Right, so that is our upthrust. This is our upthrust, okay, which makes upthrust resultant. Okay, so because there's a difference in pressure that's being experienced on two different surfaces, because the displacement is different, right, between those two surfaces and the water, this is what's going to generate this this resultant upwards force, right? But how does this relate to Archimedes' principle? Right, that's the second part of our problem, and it relates because Archimedes' principle states that the upthrust exerted on a particular body immersed in a fluid, whether that's partially or fully, it doesn't really matter, that is going to be equal to the weight of the fluid that the particular body displaces, right? So the weight of the fluid displaced by our submerged body is going to be equal to the upthrust, okay, and that is what Archimedes' principle states, right? So it's worth noting that upthrust is a consequence of pressure difference, okay, and we've shown that here, okay, quite nicely, and it's also important to know that upthrust is a resultant force, okay. Okay, so hopefully that's helped you understand upthrust in a bit more detail, and you can now kind of see the mechanics and how it's working. Okay, super interesting stuff. So obviously, as always, please like and subscribe, share, really helps the channel grow and us get more quantum content to you guys. But in the meantime, I will see you in the next video. Bye.